Okay, let's differentiate x times y equals 1. And before we attempt implicit differentiation, let's do this the more typical way. Since, of course, it's pretty easy to get y by itself, all we need to do is divide both sides of this equation by x. And then we realize we're dealing with the basic reciprocal function here. So to start to prepare us for implicit differentiation, let's make sure we're 100% clear that if I write y of x, I'm saying y is dependent on x. It is a function of x. And before we do our derivative, now that this is written as an explicit function, let's switch this to a power so we can use the power rule. And our derivative is going to be minus x to the power of negative 2. And continued up here, why don't we rewrite this a little bit, again, to try to prepare us for implicit differentiation. Our derivative is going to be minus 1 over x squared. Now, the way implicit differentiation works is that your function usually shows up somewhere in your derivative when you do differentiate the implicit function. So let's see if we can find a y equals 1 over x hiding in our derivative here, of course, that we found by getting y by itself and just using our power rule. So that we can extract that or pull that apart. This is y prime of x equals negative 1 over x multiplied by 1 over x. Of course, this is really just 1 over x squared, as long as we make sure we got a negative there somewhere. So why don't we just put brackets on that second one, and I realize that that is my original function, y equals 1 over x. So we can rewrite our derivative. Again, this is to prepare us for implicit differentiation. This is negative 1 over x multiplied by y. And then one more simplification, we realize our derivative that we have obtained by, again, working with an explicit function and our typical derivative rules, the power rule. Our derivative can be rewritten as minus y divided by x. So now that we've gotten our derivative through our more familiar means, again, we're now going to try to do this derivative using implicit differentiation, and obviously hoping to get negative y over x as our result. Okay, so let's differentiate this implicit function, x times y equals 1, and we're going to use implicit differentiation, so we're not going to get y by itself, even though that is trivial. Remember, we're just trying to get used to how implicit differentiation works with some familiar situations here. So implicit differentiation, we're going to find the derivative of the left and the right-hand side of this equation. So we're applying the differential operator to both sides of our equation. And we have xy on the left, and of course 1 on the right. And in the first part of this video, we took some time to make sure we were aware that y is a function of x. So when we are taking the derivative of x times y, we are taking the derivative of a product of functions. And most importantly, a product of two functions of x, because we remember we are taking the derivative with respect to x, where x is our independent variable. So now on the right-hand side, we have the derivative of 1. Okay, so on the left-hand side, we have a product of two functions of x. Of course, we're going to use our product rule. So it's going to be the first function, x, multiplied by the derivative of y of x, which is y prime of x, plus second function, multiplied by the derivative of the first function, which is 1. And then on the right-hand side, make sure we take the derivative of 1 and don't recopy 1, but take the derivative of 1. Of course, the derivative of any constant is 0. So we're looking for our derivative of y, remember, y prime of x. And of course, we can see that sitting in front of our eyes here in that first term. So we have two steps to get our derivative. First one is subtracting this y of x times 1 expression from both sides. And of course, that's just y of x. And then lastly, to get our derivative y prime of x by itself, we're going to divide both sides of this equation by x. There, in the right color for whatever it's worth. And that is gone. Okay, so there's our derivative, and usually the last thing that we have to do, since we're still writing y of x to make sure we don't miss the important point that y is a function of x. So now at this point, let's write this one last time where we can say y prime, our derivative without the of x business, is equal to minus y divided by x, which of course is what we got when we worked with the explicit version of this function. Okay, so there's another implicit differentiation example, and in subsequent examples we'll start to see that getting y by itself is not worth the hassle and sometimes even impossible.